All right, here are solutions for quiz 1 for Math 243. Let's see, the little story that's going on here is I'm trying to make some more money. So what I did is I came up with a drug, and apparently this drug is supposed to make watching basketball more fun. So what did I do in my little experiment here? I secretly gave it to 93 randomly selected college-aged basketball fans. That'll be important. And then of those people, 70% of them said that it worked, said that basketball was more fun that day. All right. So with that said, we got to answer a bunch of questions. So the first one, what is the sample in my study? So the sample is the small group that you measure directly. So it's not the group that you want to draw a conclusion about, but it's the group of people that you actually look at. So in this case, I actually collected data from 93 people. So what is the sample in my study? It's the 93. It's annoying that it doesn't write until I finish. The 93 randomly selected college-aged basketball fans. That's the sample. Don't confuse that with the population. The population is the larger group for which this sample represents. So that's important. I mean, if you read through this, you might think that, well, he wants his drug to work on everybody, so the population should be everybody. But actually, that's not quite true, because if my population were to be everybody, then my sample would just be 93 randomly selected people. But that's not what my sample is. My sample is 93 college-aged basketball fans. So because my sample must be representative of my population would be all of the college-aged basketball fans. So again, the really important thing there, and maybe I even write this, important that the sample is representative of the population. All right, sample population. Once you know those two things, you can start talking about the process of statistics, this 4-step process. The first step in this 4-step process is to identify your research objective. The research objective, so maybe I even write this in red, I'll say important to note that this refers to the population. Both the research objective and the conclusion down here must refer to my population, not my sample. That's really important. It's easy to confuse those two. So for my research objective, I want to come up with the question, the purpose of doing this experiment. I want to state that. Why are you doing this whole thing? There's a little bit of freedom in what you write here. So maybe I even write something like, one thing you could do, let's see, a research objective could be to determine if my drug is effective in improving basketball watching. For the group of how about for the people in my population? I'll write it out. For the group of all, I'm going to write for my population. I already wrote what my population was up here, so I'm going to reference it. To determine if my drug is effective in improving basketball watching, I don't know if that's good English, for the population. You don't have to write exactly this. In fact, I'd guess that nobody writes exactly this, but this basic idea, something like this. What are the descriptive statistics? Descriptive statistics are the summary of the data. So the way to think about the data is you have this clipboard that has 93 different words on there, 93 different data points. Each of those data points either say more fun, less fun, equally fun, something like that. So you got this big list. The first one says more fun, second one says more fun, next one says equally fun, next one says less fun, next one says more fun, and so on. You look at that big list, it's hard to draw conclusions because the data is not summarized, it's raw data. Descriptive statistics is summarizing that data. The way that data is summarized in this specific example is just with this sentence right here. You could get this from a relative frequency distribution. What this is saying is that 70% of those people said it was more fun. What are the descriptive statistics? 70% of those drugged. This is really hard to write. This tool that I'm writing with you could watch as you wrote each letter, so it made it a little bit more legible. Now it doesn't show up until I finish. Hopefully I can get that fixed at some point this term. 70% of those drugged noted that watching basketball was more fun. Something like that. Something like this. Really, the 70% is the key thing. The fact that I summarized all those data points with this one number here. 70% of those observations said it was more fun. True or false, and why? The drug appears to work on 70% of the 93 randomly selected college-age basketball fans. This sentence right here would be a reasonable conclusion. It's actually false. This is damn close to what your conclusion should be. However, it's really important to note that both your research objective and your conclusion should refer to your population. If you read this sentence, well, this is true. This is what happened. The drug did appear to work on 70% of the 93 randomly selected college-age basketball fans. That's 100% true. That's a true statement. However, that is not a conclusion because the conclusion must refer to the population. This does not refer to the population. This refers to the sample. Right? My sample is the 93 college-age basketball fans. This refers to just the 93 randomly selected college-age basketball fans. False. Conclusion must refer to population, not sample. So again, this is true. It's a true statement about my study. It's just not a conclusion. Conclusion has to refer to the population. This is probably my least favorite quiz. This is my least favorite question on my least favorite quiz. It feels stupid. I mean, if you get any of these wrong, you're probably like, it's so nitpicky. That's annoying. I understand that. I'm with you. Not much I can do about it. The rest of the quizzes won't be like this. They're not as nitpicky as this one. Second question, it's a little bit more straightforward. Each of these variables involve either quantitative or qualitative data. Quantitative, maybe I can write this somewhere. I'll write it down here. Quantitative means we're talking about numbers that have where the average makes sense. Qualitative, you're thinking more qualities, categories, that kind of stuff. So the first one, determine whether each of the following variables are quantitative or qualitative. Whether watching basketball was more fun, less fun, or about the same as normal. So you're running an experiment like the one I have up here, and each of your data points tells you one of these three things. More fun, less fun, about the same. That is qualitative. These are not numbers. These are categories. They're qualities. So this data is not quantitative. It's qualitative. Not numerical. I'll just leave it as the answer. Qualitative. Fine. A ranking from 1 to 10 of how fun basketball watching was. Similar, right? A and B are similar, but the data is different. Here, each data point says a word or a phrase, a couple of words. Down here, each data point is a number. Being a number is not enough to make data quantitative. However, these numbers, a ranking from 1 to 10, is quantitative because I could average them out and make sense of my result. Quantitative. If you gave it a 3 on a scale of 1 to 10, but I gave it a 9 on a scale of 1 to 10, and somebody else gave it an 8 on a scale of 1 to 10, I could average those out and say, on average, we got a 6.7 is our average score on a scale of 1 to 10. Sure, that average would make sense. This is quantitative. Number of cups of coffee that a student drinks during the week. That is quantitative as well. This one, much like this one, is a discrete quantitative variable, meaning I don't know, I guess you could have drank 1.3 cups of coffee, but what I had in mind is either 1 cup, 2 cups, 3 cups, but that's fine. It doesn't matter whether it's discrete or continuous. The fact is this is quantitative data, because if I drank 10 cups and you drank 2 cups, on average we drank 6 cups, and that average makes sense. SOUID, this is the trick question. This is not quantitative, it is qualitative. How is that qualitative? It says right here, number. You told me numbers meant quantitative. Yes and no. Numbers where the average is meaningful are quantitative. If we average your SOUID number and my SOUID number, that average number has no meaning. These are qualities, categories, not quantities. This would actually be qualitative. And then finally, the grade in a given class. I claim that this is either one. Like, you don't know. There's no way to know if this is quantitative or qualitative until you see the data. And that's what I want you to argue. Argue that it could be quantitative or it could be qualitative. Well, it could be quantitative. Quantitative, that's the one where we're talking about numbers, where the meaning makes sense. Quantitative, if grades are 4.0, 3.0, etc., or 90%, 80%, etc. If this is what we're talking about by grade, fine. I got a 95 on my paper, you got a 99 on your paper, she got an 82 on her paper. We could average those out and figure out our average score. Sounds quantitative to me. However, if that's not what you had in mind by grades, then it would be qualitative. If you're picturing A, B, C, etc., or pass, no pass, stuff like that, now all of a sudden it's qualitative. These aren't numbers anymore. They're categories. These people fit into the A category. These people fit into the C category. It's qualitative. So this last one, really the point was just to show you that it's a little bit unclear sometimes until you see the data itself. If you just describe the data like I did in A, B, C, and D, it's hard to know. But hopefully in A, B, C, and D, they were clear enough that you came up with these answers. All right, that's the end of this quiz. Thank God, because like I said, I don't really like this quiz. If you hated this quiz, sorry. Hopefully you won't hate the rest of them. But I'll end this video here.